Okay, tonight I was studying these things I call vector cubes. They're just the magic ghost number cubes, but with arrows pointing down or up to the pairs of inner ghost numbers in purple. They go from smallest to largest, and this is a group of what I call first order vectors. This is an addition cube. This is a multiplication cube. And I'm taking a line from something I read. Every topic in linear algebra is going to center around two operations, vector addition and multiplication by scalars. This is an addition cube. This is a multiplication cube. Um, these are second order vectors. Second order vectors that are ones that are in the box. Well, the ones that are pointing towards these numbers. For an addition cube, they're always going to be whole numbers. They're always going to be whole numbers. And I did some sort of math with this. Well, I'll show the multiplication cube first. It blows up. I didn't bother to do anything down here, and I'll get to this. But if you take 216 or 13,824 and divide it by 216, you get 64. You take 216,000, you divide it by 3,375, you get 64 again. Back here, you take 1,000 or 110,000, and I can't see that too well, but I think it's 529 or 629 divided by 1,728, you get 64 again. Same thing down here, front to back, from front to back, from you get 64. Then you go on this way, from this front to back, and this front to back, and this front to back, and this front to back, you get 15.625. And when you go from bottom to top, dividing the bottom by the top, bottom by top, bottom by top, and bottom by top, you get 8. So I did some sort of math with this. Multiplied 64 by 15.625, which is this fraction number. You get 1,000. So that's it. Divide them and multiply. Okay, I multiplied 8 times this number again, and I got 125. 125 goes into 1,000 8 times. So I tried to do the same thing over here, and it's just redundant, I guess. 9 times 9. 9 times 9 is 81. 9 times 9 is 81. 81 and 81 go into each other one time. So it didn't, I don't know. It didn't really show anything. So what I was trying to do to begin with in the beginning of the night was trying to figure out why I didn't bother to do the multiplication because it's just so large. But with the addition cube, I tried to make a span, a three-dimensional span that may be the volume of the outer ghost number 63. There's a 18 right here, 27, 36, 30, 27, down here 36, down here 36, back here 27, right here 45. Well, I tried to give them the span as I could, as accurate as I could, and I can only guess that this span, this three-dimensional span of these vectors, these inner ghost numbers, all add up to 63 in volume, whatever that might be. So lastly, I had to change this, but what I have now is addition cube second order vectors are always whole numbers, and multiplication cube second order vectors may contain whole numbers and or fractions. And this is something I worked on previously, first and second order vectors and scalars and magic Gaussian cubes. These are scalars. These are double helix. Anything with the same inner ghost numbers on both sides, all the way around. They're all scalars. They don't have no direction. But these are vectors. And these second order, these are first order vectors, of course. And I was trying to study them. Here's pictures of some more. And I tried to study the second order vectors. And at first I came to the conclusion that all addition cube second order vectors, are all whole numbers. And that's right so far from what I've studied. They're all whole numbers. But the multiplication cube can be whole numbers, or it can be fractions. And it can be whole numbers or fractions, or they can just all be whole numbers. Here's the multiplication cube. And these are fractions again. These are fractions. These are fractions. These are fractions. And those are the second order vectors. And so that's the work I did on these things tonight. I did this some time ago, and I just added this to what I've been studying tonight. So they're vector cubes with first and second order vectors. Thanks a lot. Bye.